All right, let's talk about NoSQL injection. But listen, this isn't going to be some dry academic lecture. Nope, this is a story. It's a story about what happens when cybersecurity theory crashes into the real world and, well, reality puts up a pretty good fight. In this quote, it nails it, right? It's from an engineer who walked into their first real-deal NoSQL security test, totally expecting a quick win. Instead, they got something a whole lot more humbling and, honestly, way more interesting. So yeah, we're going to walk right through the missteps, the wrong turns, the whole shebang from that experience. Because let's be honest, learning from someone else's mistakes is always the cheaper option. And in this breakdown, we're going to see exactly how these errors actually light up the true nature of modern NoSQL threats. Every good story's got a beginning, and this one kicks off with a healthy dose of confidence meeting a pretty embarrassing reality check. It's a moment I think probably a lot of us can relate to. Oh man, can you feel the pain here? Almost an hour just spiraling, absolutely convinced you found this massive, critical vulnerability, only to realize the bug is in your own diagnostic code. It's that classic trap of looking so hard for the complex problem that you completely miss the simple, obvious one right in front of you. A humbling start for sure, but a super important part of the journey. So after recovering from that little false start, the first real mistake came into focus. And it wasn't a technical one, not really. It was a mental one, trying to solve a brand new problem with a really old map. Okay, now what's so fascinating about this is the huge shift it shows. With old school SQL injection, you're usually trying to break out of a string, to literally smash the query's grammar. But with modern NoSQL injection, you're not breaking the syntax at all. You are reshaping the logic. You're not sending a broken piece of text, you're sending a perfectly valid object. Something like this little .NE operator here, that tricks the application into asking the database a much, much bigger question than it was ever supposed to. And this is the real cost of that outdated thinking. 30 minutes. A full half hour of that initial test was just wasted, throwing totally irrelevant attacks at the wall, hunting for quotes and comments that had absolutely nothing to do with the actual risk. So once the mindset was recalibrated, the next mistake popped up, just looking for danger in all the wrong places. It's all about where we choose to focus our energy. You know, we instinctively zoom in on the high-stakes stuff, like login forms. They get all the attention, all the security reviews. But the real danger? It was hiding in the most boring, mundane feature you can imagine, a simple search filter. And why is that? Because login endpoints get hardened, but search features are often rushed, built with creative shortcuts that are designed to accept all sorts of complex inputs from the user. And this is the question that always comes up, right? It's a totally fair point. We have these big security tools for a reason. Can't we just lean on our firewalls to catch this kind of stuff? And the answer, pretty much, is a hard no. Look, a WAF is great at spotting stuff that's obviously broken or matches a known bad signature. But a malicious NoSQL injection payload, it often looks like a completely valid, totally legitimate request. It's just a JSON object with a filter. The WAF has absolutely no way of knowing that the logic inside that filter is designed to completely sidestep the developer's security intentions. So this brings us right to the heart of it. After we peel back those layers of old thinking and strategic blind spots, the true nature of this vulnerability finally shows itself. The big aha moment is this. We have to call it what it really is: structure injection. And the name actually matters because it completely changes how we think about the problem. We are not injecting a string to break syntax. We are providing a perfectly formed structure, a JSON object that the application just happily accepts and then uses to change the very logic of its own database query. And hey, don't think this is some old legacy code problem. This threat thrives in our modern development stacks, where convenience is everything. We're talking about Node APIs that pass request bodies straight into functions, GraphQL resolvers with super flexible arguments. Basically, anywhere a developer uses a helpful library that accepts a query object right from user input, this risk is just sitting there, waiting. So, what does this actually look like in the code? Well, there are a few key patterns you need to hunt for. The absolute biggest red flag is any code that takes an object from a user and passes it directly into a database filter. You also got to watch out for dynamic keys, where the user can pick what field to filter or sort on, and especially the use of powerful operators like not equal or greater than without super strict validation. Okay, enough theory. The real lesson from this whole story wasn't just about finding one bug. It was about building a fast, repeatable process to find it again, and more importantly, to defend against it. So let's look at how you can turn this knowledge into a practical skill right now. This is it. This is the streamlined workflow that came out of all those painful mistakes. It's simple, it's efficient. First, just make a list of all the places in your code that build query objects from user input. Second, figure out which ones touch sensitive data and start there. Third, test the riskiest ones in a safe copy of your environment. And finally, and this is so important, make sure your "are you allowed to see this" checks happen completely separately from your "what are you looking for" filtering logic. And on the other side of the coin, here are the defenses that actually work. Don't just accept any random keys from the user. Have a strict whitelist of the ones you allow. Use a schema to validate everything. Never just spread a user's object into your query. Explicitly map the values you care about. And like we just said, always, always, always keep authorization separate from filtering. All right, so here's a direct challenge for you. The absolute best way to go from just understanding this to really knowing it to building that muscle memory is to do it yourself. This little 15-minute challenge is a safe way for you to experience both the vulnerability and the fix. Build it, break it, and then fix it. I promise you, that little loop will teach you more than hours of just reading about it. And that brings us to the end. The big lesson from this entire journey is that the most serious risks aren't always in the flashiest, most complex features. Sometimes it's the quiet, boring parts of an application that actually hold all the power. So I'll leave you with this to think about. Which boring feature in your app might be the real master key?